The objective of the feature generator is to create a box, given the height, width, depth, and wall thickness. In addition, the user is allowed to put as many holes as they want, of any size, onto any face of the box. This seemingly straightforward problem is still complex enough to highlight the benefits of a generative configurator over one that is master model based. When creating the assembly in SOLIDWORKS, each unique side must have its own panel file. What is less obvious, but equally important, is that when two or more sides are the same, they should share the same panel file. Each unique panel gets its own part number. When the same part number is assigned to more than one SOLIDWORKS file, it complicates downstream drawing, BOM, PDM, and ERP functionality. A master model-based configurator begins with a master assembly, created in SOLIDWORKS. You then write rules that are used to reconfigure the master assembly, morphing it into the desired assembly. A generative configurator begins with individual component assets, not a master assembly. You write rules that are used to configure an engineering model describing the assembly you wish to build. The system uses this engineering model and its own built-in rules to automatically generate the corresponding assembly in SOLIDWORKS. The first step in using a master model-based configurator is to create the master assembly. How the master assembly is built depends upon the available functionality in the configurator. Most master model-based configurators are limited to resizing and deleting portions of the master assembly. Every variation that might exist must pre-exist. Such a master assembly begins with 6 panel parts. Each panel is created with a number of pre-existing holes. The holes that are not used will be deleted. This can quickly become impractical if there are many different types of holes or if a large number of holes per panel is common. It also means the user interface must limit the number of holes that can be added to a single panel. When assembling the box, the bottom is made with panel 1. The top is made with panel 1 or panel 2. The front is made with panel 1, panel 2, or panel 3. Likewise, the back has 4 alternatives, the right 5, and the left 6. Every possible panel is included as a component in the assembly, resulting in an assembly consisting of 21 components. The process to create our box would then be to delete the 15 unused components and any unused panel parts, and then reparameterize the required panels. If the master model-based configurator includes limited generative functionality, such as the ability to replace one component with another and the ability to insert features into parts, the master assembly can be simplified. Such a master assembly would still begin with 6 panel parts, but with no holes in the panels. The assembly contains one unique panel for each side of the box. The process to create our box would then be to configure the sides one at a time. If a side is unique, reparameterize its part, adding holes as needed. If the side is the same as one already configured, replace its component with the appropriate part. Finally, delete any unused panel parts. Rules must now be written to reconfigure the chosen master assembly. The simplest rules to write are those that size every panel and size and locate every hole on the appropriate panel. In addition, rules must be written to delete or add holes in each panel part, to recognize when 2 or more panels are the same, to delete or replace panel components in the assembly, and to delete unused panel parts. These additional rules are both application-specific and procedural, which makes them very difficult to write. Fortunately, they are also completely unnecessary. Genus Designer is generative. The only rules you need to write are those that describe how the holes are added to the panels and how the panels are arranged to form the box. To create a new box, you run a solution in SOLIDWORKS. First, size the box by entering the height, width, depth, and wall thickness. To add a hole, choose a side, a type of cutout, and set the cutout dimensions. Locate the center of the cutout on the face and select Add to List to add the hole. For this example, we will add a second hole to the right side and a third hole to the top side. After all the holes have been entered, choose Create to generate the box. The system uses your rules and the user inputs to configure an engineering model of the box. Then, based on that engineering model, the system generates the corresponding SOLIDWORKS assembly. Because the engineering model was created first, the system can determine when one or more panels are identical and simply use the existing panel rather than creating a new one. As shown on the assembly drawing, each unique component gets its own file, and the BOM quantities are correct. Notice also that there is only one drawing for each unique panel, and the holes, which are added by rule, are properly dimensioned on the part drawing. Master assemblies can be difficult to build and maintain, and master model-based configurators can only rearrange the master assembly they are given. Generative functionality is required for open-ended problems. It is true that if a system cannot add a component to an assembly, or a feature to a part, by rule, then it cannot be considered to be generative. But it is also true that simply providing access to these functions in a procedural way does not make a system generative. Generative functions can simplify the master assembly, but at the cost of complex rules used to insert and position elements at the right time in the configuration process. Regardless of the master assembly used, a master model-based configurator also forces you to face the full complexity of file management and embed this knowledge into your configuration rules. The fact that you do not need a master assembly is what makes a system generative. An independent engineering model gives you a place to declare your intentions before committing to any geometry. This makes it possible for the system to take full responsibility for the order of operations and all file management, generating the optimal SOLIDWORKS assembly.